Okay, very good. This is ITS128, and this is class number 3, I guess. And so today, let's look at our syllabus. I go to here. Oh, this one. So we are doing these 1, 2, 3, 4 challenge activity. These Xylabs. So we're doing class number 4. This is class number 4. This is Thursday. And class number 3, I went through the whole chapter, but I didn't do any of these Xylabs. So this time I'm going to cover these Xylabs. Okay, so excuse me. Oh wait, I'm sorry. I wasn't. I would need to share my screen. Sorry, I wasn't sharing my screen. Okay, so let's go look at these Xylabs. Okay, so today we're gonna go over the Xylabs for chapter 2. And 1, 2, 3, 4, 5. There's 5 of them, and you should have gone through the chapter and participated in the exercise, the participation assignments or whatever they're called, uh, and um, and hardening up the syntax of the language, operator precedence, and so on. So let's take a look at what the assignments are, or the labs at the end. Okay, first one, divide by x. Let me see. Let me open up chat. 2.7.2. So somebody just asked if I go over 2.7.2. It's 2. Let me find 2.7. This 2 points modulo. Oh, sure. Why don't I cover modulo? Okay, so modulo is just like, you remember when you're in grade school and you learn how to divide. You hadn't learned about fractions yet. You just, how many times does 3 go into 7? Well, it goes in. 3 times 2 is 6, so that takes care of 6, so it's 2. But then there's this extra one left over. That's the remainder. So that's what the modulo is. And so determine the result. Type error if it's inappropriate. Okay, so these are expressions. These are expressions. And so what is 50 mod 2? Well, 50 mod 2 is this. It's 50 divided by 2, and then what's the remainder? Well, 50 divided by 2 is 25, and there is no remainder because it goes in evenly. So it's 0. So there is no remainder. It's 0. So 50 divided by 2 equals 25, and the remainder is 0. So that's the mod. Okay, so 51 mod 2 is 51. Let's see, divided by 2. Let's see, is this how you do that back in the old days? 51. So what's 51 divided by 2? Well, it's 2. It's 4 minus 1. Bring this down, and 10. So 5. And then minus. So then you get 11 minus 1 is 11. Here, can I do this? 11 minus 10 is 1. And so 1 is the remainder. R equals 1. So 1 is the answer to this one. And 0 is the answer to that. Okay, so 78 minus 10 is, when it's divided by 10, it's easy because they're all, let me see, I think I can just erase this. So 10 divided by 78 is 7 times 10 is 70, and there are 8 left over, and so that's the remainder of 8. So and you see a pattern. It's actually just the lowest order digit. It's always just the lowest order digit. So this one is 8, and this one is going to be 6. It's always the lowest order digit. We have I'll do this. You have 10 divided by 596. 50 is 5, 50, 9, bring down to 6, and it's 90, it's 9. 9 times 10 is 90. 6, remainder of 6. So lo and behold, it's that lowest order again. So it's 6. And now this one, first you do the 1 divided by 2. Well, this is 1 divided by 2. Okay, so we're doing 100 mod 1, but it's this integer divide by 2. So first you do that. Well, 1 divided by 2 equals 0.5, right? But when we do a double slash, we hack off anything to the right of the decimal point, and we just use this. Okay, so 1//2 is just 0. It's not 0.5, it's just 0. So now we have 100 mod 0. Well, you can't divide by 0. It's against the rules. So if you have, so that's an error, and that's an error way down in the got it. Way down in the microprocessor itself actually detects that error. Okay, so anyway, so this is error, and the microprocessor won't let that happen. All right, so challenge activity 2.2. Okay, this one. Okay, this one. Okay, so change for $19. Okay, so first of all, you're adding. Did I? Oh, this is already started. Okay, and we got to write what's in here. So the cashier distributes change using the maximum number of $5 bills, followed by $1 bills. Write a single statement that assigns number of ones to the number of distributed $1 bills given, with the number of distributed $1 bills given the amount to change. Okay, well, anyway, it's first of all, how many 5s? Okay, amount to change is a value, and in this example, it's 19. And we want to know what number of 5s is going to be this 3 here. That's what that is. And then we want to figure out what this is. This one. We want to compute num1s. Num1s. Well, we want to subtract out the this came up to $15, and we want to subtract that out of the 19, and that's what's left over. Okay, so so this ends up being 3, and then we got to go num1s is going to be equal to amount to change, which is amount, and we need to subtract out the $15. Subtract out the $15 would be num5s times 5. So there's going to be 3 of them. So that's number of 5s is 3 5s times 5. That's $15. So here we're subtracting the $15 out of that, and that's going to equal to the number of ones. This is slow. I gotta. Oh, something went wrong. Okay, there we go. Yes, so that works. So it tries it for $19, and it says it got that, and then it tries it for $6, and I got one. Okay, so anyway, that's pretty easy. Okay, so these challenge activities can be pretty difficult. I can see, and they don't really do a lot to help you when it's wrong, other than just to let you run it and you're able to look. So it's really good that they gave you this example here. In fact, it's pretty hard for it to be wrong if you just take the direct approach and make this work in your code. All right, so let's. I'd like to go back to uh, these labs here. So the first one, write a program using integers, using this and this as an integer as inputs, and output divided by x 3 times. Okay, so input user num and x. I just noticed that, yeah, that would work too. I just noticed that if you look in the chat, you notice that Maria pointed out that you could do mod, the amount of change mod 5, and that would give the number of ones, and that works. Yes, that's very good. Very good to point that out. In fact, that might have been that might even be a preferred answer. So anyway, back to this one. Okay, so what we're supposed to do is we're supposed to input a number, and then we're supposed to input another number, and then we're supposed to print out the first number divided by the second number, and then the first number divided by the second number divided by the second number. In other words, divided by the second number again, and then divided by the second number a third time. So when you have 2,000, you divide it by 2, you get 1,000. You divide that by 2, you get 500. Divide that by 2, you get 250. Okay, and so you're just supposed to write the code to print this out. Okay, and so I put this down here. I think the first time you do this, it's not gonna you aren't gonna have this down here. I put that down there because I've done this already. Basically, you're just doing you want 3 numbers. Okay, well, okay, so it's really easy way. Let's do it more of a brute force way. num1. Oops. Oh, we have to input the stuff too. Okay, so user num equals int input. Okay, so that's gonna grab the first one is gonna the first number that's entered in is gonna go into this user num, and the second one that comes in is gonna go into x. And then you're going to print out print okay, well, you're going to print out x. Here, I'm just going to do this way. N1 equals user num divided by x, and N2 is equal to N1 divided by x, and N3 is equal to N2 divided by x, this integer divide. And then you can just print, N1, N1, N2, N3. See if this works. Run the program. That looks pretty good. So then I can do submit mode. Anyway, see this down here shows my work. So anyway, I think that's probably a good answer. So what's next? Driving costs. Oh, this one. Okay. So you're supposed to input the car's mileage, number of miles per gallon that the car gets, and then the cost of a gallon of gas. So you input the miles per gallon and the cost of the gas, and then it'll output how much how much gas costs for driving 20 miles, how much you pay for gas to drive 75 miles, and how much you pay for gas driving 500 miles. Okay, so you've got miles per gallon, and you've got dollars per gallon. Okay, so you have make this is small maybe. So for example, you've got 20 miles per gallon. In this example, you've got 20 miles per gallon, 20 miles per gallon, and you have 3.16, I'll just say, dollars per gallon. And you want dollars. You want dollars. So, you want dollars per mile. And then you're going to multiply dollars per mile by the number of miles. So from this, you want to figure out the dollars per mile, And then you can multiply that by 20, or you can multiply that by 75. You can multiply that by 500. Well, what do you do with these two things to end up with dollars per mile? Well, you've got this dollars here, dollars on top. You have dollars on top here, and you have miles on the bottom here. So let's start with this 316. Oops, let me erase this. So I've got 316 dollars per gallon. And if I divide that by 20 miles per gallon, then these two G's cancel. This cancels because that's a denominator there and there's a denominator there. So those cancel, and we end up with $316 over 20 miles, which is what we want, dollars over miles. So 316 divided by 20 times whatever the miles is. So if we do, I'm going to do dollars per mile equals 316. Oh, no. X. No. What's this? What do we? Oh, we got to input these. Oh, I got to name these somehow. Okay, I got to input these. Okay. Miles per gallon equals float input. Okay. And then we have, what's the other one? Dollars per gallon equals float input. Okay, so the second one's going to be this dollars per gallon. And then we've got dollars per mile equals the dollars per gallon, which is dollars per gallon over the, it's this thing, that divided by that. So that's miles per gallon. Miles per gallon. Okay, so we have dollars per mile, and then so then we've got 20, 75, and 500. So, and that's cost. Okay, so I'm going to say cost 20 equals dollars per mile times 20. And I can say cost 50 equals dollars per mile times 50. And I can say cost, is that what? Oh, 75. Got it. Okay. 75. Oh, yeah, I'm just going to do this. Cost per 75 equals dollars per mile times 75. And then I got to print all that out. I'm going to say print cost per 20, cost 20, cost 75, and cost 500. Underscore 500. $79.0. Wow. 11.85. Oh, I got to do it this way. Let me grab this, copy, and I'm going to do this. I'm going to do this. I'm going to do this. I'm going to grab just this, copy, and I'm going to paste it. No, I'm going to be even fancier than that. I'm going to do this. I'm going to grab this. Copy. Paste. And I need to put another one of these here. Okay. All right, that looks pretty good. That's pretty good. Now, you could just do, you could just put something right in there. You could put a um, 20 times dollars per gallon divided by miles per gallon. And so in other words, you can bypass the variables if you want to. You still need to grab those as inputs because you use them more than once. If you only use them once, you wouldn't even need this, but you're going to use it more than once, so you got to have that. But anyway, this should give you the same answer. So, okay. Anyway, let's see what else. Yes. All right. That's 342. All right. What's the next one? Okay. This again is an exercise, and we've got women's calorie. How you compete. How you compute how many calories a woman burns, depending on the age, the weight, the heart rate, and the time amount, the amount spent. And then men, it's a different formula. And then they want you to print it out like this. Okay. So first compute, you want to compute the one for women, and you want to compute the one for men. So in other words, if you input something like this, it's going to display out something like this. And so the trick, of course, is to take this formula and convert it into something that looks like that the computer can understand. So first you got to read in these numbers. So I'm going to say age equals int input. Then I'm going to say weight equals int input. And I'm going to say heart rate equals int input. And I'm going to say time equals int input. So that's time in minutes. Minutes. Maybe I'll call that minutes instead. All right, so I got these four numbers, and then for women, it's going to be something like women equals, and you got to convert this into something that looks more like this. So I'm just going to grab this. Is that the formula? It ends like that? Okay. Well, it doesn't matter which one I grab. I can grab this one. They're the same. Grab this and put that there, and that's messed up. So this is a times, and this is a times, and this is a oh uh, yeah, all right. This is age. This is weight. This is heart rate, and this is I said well, whatever, minutes. And this is a times, and this is a times. All right, and then you can say print women, women, women. That's the variable for women's calories. Calories. So I'm going to see what this does. I'm going to say these numbers, and I'm going to run it, and I get what you know what doesn't like about that? It's some other. It's not really a dash. It's a different character. So I'm just going to overwrite it with a little minus sign there. That's nuts. It's right up here. It looks like. All right, let's see what this does. Run the program. Okay, I got this for women, 589.33. Ooh, okay, so it's rounded. Well, it's got to do something like this. No, okay, let's do this right. Quote, women, colon, dot 2F, 2F floating point, close the stat, calories, period, format, women. Let's see if that looks right. $580.94. Yes. Okay, so that works for that. You got to do it for men. Should be easy. All right, what's next? Math function. So we're supposed to, this one. We're supposed to read in these three numbers, x, y, and z, and then we're supposed to display out x to the power of z, and then we're supposed to print out x to the power of y to the power of z, and then we're supposed to print out the absolute value of x minus y, and then we're supposed to print out the square root of x to the power of z. And we're supposed to use the math function. So let's find math functions. Python math functions. Let's just see what this one says. Okay, we're going to want to use absolute value. Is that a floating point number? Yeah, it's floating point number. So let's put this down here for one. And I'm going to input the stuff. X equals float input, y equals float input, z equals float input, and we're going to print out this somehow. Copy this and paste it down here. And we got four of these. We're going to say your value 1 equals something, your value, still I'm using these variable names, but who cares, which equals your value 3 equals your value 4 equals, and this is x to the power of z x to the power of z, and this one is this, and this one, next one is absolute value of x minus y, and the last one is square root of that. All right, so I'm going to do the last one. I'm just going to do the last one. You're going to do these ones yourself, and I'm going to do the last one. So I'm going to use the square root and power. So I'm going to use, oh, by the way, you're going to use this one for absolute value. I'm going to use power, and I'm going to use this one. Oh, they're right next to each other. SQRT and power. Okay, so I'm going to use this one first. Well, let me just type it in. So first I'm going to do x to the power, well, math square root, SQRT, and then x power, x to the power of y, math power x comma y. No, x comma z. X comma z. And I got to do this. I got to do import. Yeah. I think that works. Okay, I'm going to see what this says. Run program. The last one is 13.13. Is that right? Ooh, yes, it is. Okay, so you can do, there's a similar formula you got to put in there. You got to put another, it looks like this, x to the power of z. And then this one, you're going to have to do x to the power of, so math pow x comma, and then whatever this is. Anyway, you can figure that out. What's the next one? Musical notes. Wow, this is a tough one. All right. So a piano. Okay, we're going to start out by you enter in an F0 frequency. A key has a frequency. So you have a key, you know, piano key. Ding. On a piano, a key has a frequency of, let's say, F0. Each higher key, black or white, has a frequency of F0 times R to the N power, where N is the distance that is the number of keys from that key, and R is 2 to the 1/12th power. So R, this R here, is this number here. So first you can compute this number, and then you do this, and you multiply it by this to get these numbers. First you get the 440, and then this is 440 times this to the 1 power. Yes, n is 1, 2, 3, 4. Okay, so well, let's read in that. Let's read in F. It's an integer, F0. F0 equals int input, and that's going to bring in F0. And then let's compute R. R equals math power 2 to the 1/12. Okay, that's what math is. I better bring in the math module, the math import math, import math. Okay. So that's what 1/12. Okay, so this is R. That's going to be R. And then we're going to do, I'm going to call this is F0, this is F1, F2, F3, F4, according to this formula. And being, okay, so I'm going to do, I can compute an F1 equals F0 times R to the n power, math power R, comma 1, which is dumb because it's just that, just R. And this F2 would be F0 times math power R to the 2. I think that's right. So I'm going to see what this looks like when you print it. I'm going to call this F1, I'm going to call this F0, and I'm going to call this F1, and I'm going to call this F2, and I'm going to get rid of these. You have to do it. You have to do yours correctly. 1, 2, 3, 1, 2, 3. Okay, so I'm going to see what this looks like, and I'm going to enter in 440 on the program. Okay, I got 46616, 49388. Okay, it looks pretty good. So you can carry on. What's next? Is that it? Did I do all of them? Oh yeah, I guess I did. Okay. All right. Are there any? Does anybody have any questions? So I was going to do that. Somebody asked me a question about this main name equals what? Was that in this chapter? Um, yeah, I think that was in this chapter. You know, I don't even want to. We don't need to talk about that yet. Somebody asked me about. Oh, well, thanks. Let's see. Ah, modules, right? Modules. Yes. Ah, this, yes. Okay, so in this example, it's too early for us to talk about this, but in this example, we have two modules here, and one and we have a module here called print name, or we have a program called print name, and it imports another module. Now, you you recall in the exercises we were just doing, we actually imported this math module, and that way we were able to take advantage of these extra methods that the math module provides. Okay, so in this case, and we did it by importing. Well, here we're importing again, but we're importing something that we named. Okay, we have this other file here called names.py, and it does these two assignments here. It assigns the variable first. It assigns that equal to the string Larry, and this assigns it to David. And so once this is here, then it's just like these two statements are right there. Oops, right here. Well, you know what I mean. So then, but when we refer to first and last, since we're over here, we cannot just say first or last. We have to prefix it because it's imported from this thing. So if we say this names dot first, then that's going to actually print out what this over here is, and names dot last is actually going to print out what this over here is. So this hi Larry David is how this prints out here when this one is run. Okay, now, okay, fine. Now, sometimes you'd like to be able to, in your module, sometimes you'd like to know if this module is actually being imported by something else. We want to do one thing, but if the module is actually being run all by itself and not being imported but running as its own standalone thing, then we want to do something different. Okay, that's what this is all about. Here we have these two. We have two modules here. We've got this one here is called baby names, and this module here is called favorite child. And in this module here called favorite child, it imports this baby names module. So in other words, this is like the master. That's a bad term. We actually don't use those anymore. This is like the boss. This is the main, and this is the subordinate. Okay, so um, so so in this case, we're using this name thing. Yeah. So if what this is saying is if this module here, if this module is being run all by itself on its own right. In other words, if you're running it like this, where you actually run it, then it's going to print out this stuff. Why? Because this evaluates to true. This is true. It's true that this special variable name is equal to this. And since that's true, it's going to print this stuff out. However, in this case here, when we're running this favorite child, which is this, well, this whole thing does get executed because of the import, but this does not end up being true because this module was not run on its own right like this. This module was run because it was imported. Excuse me. Now, the problem I have with introducing this concept now is because there's just too many things that we haven't come to yet. First of all, double equal sign. What does that mean? Okay, well, it just means it's a test. And then we got these underscores here. We haven't really talked about that yet. And we have this if thing. This is a branch. This is a branch where we're testing it. We're testing if it's equal because this means equal inside of a so anyway, there's just too much here. But anyway, so that's why I kind of brushed over it last time. But later on, as soon as we start talking about branching, which is in branching down here, it's in chapter 4, we have if branches, if else branches, and so on. So then we start getting into that, And by the way, expressions. Do we get into Boolean expressions? No, we didn't, did we? No, we didn't. We didn't get into what types. Well, anyway, so that's the answer to that question. And we will talk a lot more about that next time, and or when we get down there, and I'll come back to this and sort of remind us about this thing, and after we've covered both that double equal sign and branches, it'll make a lot more sense to you. And modules too. We haven't even really talked about where we write some modules and then we use those modules in some other program that we write. So that we aren't going to really get to that until down here, chapter 11. So so that's really kind of all I have today. Um, does anybody have any questions?
Yeah, I have a question.
Yes, go ahead.
Yeah, is chapter 3 due?
Is chapter 3 what? You're muted again.
Is chapter 3 due next week, Friday,
Okay, chapter
the
3.
11th?
Let's see. Chapter 3 would be
Is
due.
it the 11th or the 13th?
No, see, chapter 3 is a 2 week thing, so it's going to be due, two more weeks later. So it'll be what is it? Do I say when these are due? Do I really say when these are? Oh, I don't have anything here. Um, okay, so all right. So first of all, you just let me point out. I don't really. These due dates are kind of recommended. Try to keep up. But I don't really like if something comes up in your life and you got to set this aside for 2 weeks and you end up being a little bit behind for a while. That's no big deal. Okay, just at the end, these are all auto graded. We can do this because it's auto graded. Okay, so because it's all auto graded, we can go wait till the end after you got to have everything handed in. Day before I have to turn my grades in and I dump out everybody's grades and then there. And so, um, I don't really. Uh, it's like I don't like artificial deadlines. Now if I have to grade this stuff manually, then yeah, we need deadlines, and then it's my schedule. Okay, let's see. I'm gonna go to my nephew's wedding on that day, and I gotta have your stuff. So it's my schedule. But when you're doing auto grading, but try to keep on asking questions. Okay, so the question is, okay, chapter two is a 1 week chapter. Chapter 3 is a 2 week chapter. So I'm not going to have I won't expect everything to be done until the end, till just before it's kind of like just before we start chapter 4, then try to get all the chapter 3 stuff done. And chapter 4 is a 2 week chapter also, so we got some time there. It takes 2 weeks for that. Chapter 5 is a 2 week chapter. Oh, chapter chapter 5 is chapter 5 is a 3 week chapter. A lot of stuff in loops. Okay, a lot of different ways of making loops. So that's a 3 week chapter. So that's not really, you know. And then 6 is a 3 week chapter. Also functions. Yeah, that's important stuff. Strings is pretty. Should spend more time on strings, but we don't. And then lists and dictionaries is 2 weeks and 3 weeks because Thanksgiving's in there. And then classes is they're called classes. That's 1 or 2 weeks. All right. Any other questions?
All
Wait.
right. Thank you very much.
Okay. I'm sorry. I wasn't showing you my screen when I was doing that. When I was looking at it before, I was going down the syllabus here and pointing out that this is Oh, wait a minute. I'm sorry. Oh no, you're right. Chapter 3 is a 1 week chapter. Types is pretty fast. Chapter 4 is the 2 weeks chapter. Okay, but so chapters 1, 2, and 3, they're pretty short chapters. They're pretty. Those are only 1 week chapters. Then 4 is a 2 week chapter. 5 is a 3 week chapter. 6 is a 3 week chapter. 7 is a 1 week chapter. 8 is like a 3 week chapter, and 9 is like a 1 or 2 week chapter. Okay, that makes better sense. All right. Are there any other questions? So that's great. So I will close this up now, and I will see you next Tuesday.
Thank you.
All right.
Thank you very much.
Thank you. Take care. Stay safe.